This is Scott Howard with Buyer Security. In this video, I would like to give you a brief overview of the major features and benefits of the Tofino Modbus Enforcer security module, and we'll follow that up with a short example of how to deploy and configure and test a security system using this module. Just a quick bit of background here on the Tofino security system. All of the security features of the product are embodied in this series of firmware modules that are called loadable security modules. These modules can be deployed to each security appliance in your control network, so you can customize the security features in each zone. Also, new security modules are being released on a regular basis, so the library of modules is expanding over time. Let's talk a little bit about Modbus TCP. If you've been involved in automation for any longer than 5 minutes, you have certainly heard of Modbus. It's a very widely used protocol. It started out many years ago as a serial protocol and migrated to Ethernet when Ethernet became popular in industrial networks. Modbus controllers, so-called Modbus slave devices, allow Modbus masters to read and write binary values called coils and also numeric values called registers. And these values are accessed using commands called function codes. There's a set of function codes that are publicly documented and widely supported by most Modbus capable devices, and there's a wide range of proprietary Modbus function codes that vary depending on the specific device and vendor. So because Modbus is a very old protocol, there are some security issues involved with this protocol. First of all, the protocol itself was designed in an era when security was just not a concern for automation systems. As a result, when we use Modbus protocol over a network, there is no way for the Modbus slave device to authenticate that the master that's sending commands to it actually has the authority to do so. Essentially, if you can ping a Modbus slave, you own it. You can send any Modbus command to it that not only reads data from the device, but also writes and makes changes to the device. So clearly, sending the wrong command at the wrong time could have a disastrous effect on the plant that's being controlled. In addition, many brands of industrial controllers use the Modbus protocol to transport maintenance and diagnostic commands. For example, many of them allow you to upload new ladder logic to the device. You can set the device into test modes. There's all kinds of things you can do accidentally or maliciously to a Modbus controller. Finally, some of these Modbus capable devices have some errors in their implementation of the Modbus command set. Specifically, we found some devices that don't do a good job of error checking on commands that are sent to them. And as a matter of fact, the Tofino SCADA security simulator includes an example of one such vulnerability which can cause the PLC to crash. So clearly these are issues that in this new era of concern about cybersecurity, these are things that we want to protect against. A firewall, such as the Tofino Firewall LSM, allows the engineer to control which devices can connect to each other and what protocols they can use. But once those connections are created, the firewall has done its job and is out of the picture. We actually need another tool that can examine the communications within those connections at a higher layer in the protocol stack to see whether or not those commands are valid and to allow the control engineer to decide which commands should be let through and which should not. And that's the function of the series of enforcer modules from the Tofino product. In this case, we're talking about an enforcer module that understands Modbus protocol, and there are others available for other protocols. So the Modbus enforcer takes over where the firewall module leaves off. First of all, it looks at the commands and responses passing back and forth between a Modbus master and slave and makes sure that those communications actually conform to the requirements of the Modbus TCP protocol specification. That feature is called sanity checking. Next thing it does is that it gives the control engineer a facility to specify which function codes he wants each Modbus master device to be able to issue to a protected Modbus slave. Not only that, but for many of those function codes, the engineer can also specify which coil or register addresses each Modbus master device is allowed to access with those function codes. Now, similar to the Tofino firewall, the Modbus enforcer on Tofino behaves like a whitelist. In other words, the control engineer specifies which function codes and which coil and register addresses are accessible to a Modbus master, and any access outside of that allowed range is blocked by the Tofino Modbus enforcer, and also causes the enforcer to generate an alarm message when that command is blocked. So this gives you tremendous control over the security of your protected Modbus devices just by limiting the number of function codes that you permit to pass through a connection. You can create, for example, read-only connections where a specific Modbus slave device is allowed to read data from a protected controller but not make changes to it. You can also prevent accidents such as accidentally uploading new ladder logic to a controller that's operating on the plant floor simply by not including those programming function codes in the list of allowed commands. So to illustrate how to use this module, we're going back to the same network that we've used in previous videos in this series. It's a very simple network. We have two devices. One is a Windows PC running HMI software, and that PC is this device at IP address 1.15. The other device is a Modbus PLC, which is shown down here. It has IP address 1.1. So we're going to protect this system by inserting a Tofino security appliance in front of that PLC and adding a PC that will allow us to manage, configure, test, and monitor that Tofino security appliance after it's been added to the network. All right, let's go to our example system. So once again, we're back at our demo system. If you saw the first video in this series, this will look extremely familiar to you. It is exactly the same system with the same configuration. We have already created a configuration in our network editor consisting of an icon to represent our HMI computer, another icon representing our Tofino security appliance, and a third icon representing the PLC that we're trying to protect. If you are unsure or want more detail on how we got to this point, please refer back to the first video in this series because that details exactly what we did to achieve this particular configuration. Now, if we look at the configuration of the PLC, we see that we do have firewall rules that permit our HMI computer to communicate with our protected PLC using Modbus TCP. So what that does for us is it basically restricts which devices can communicate with this protected controller. It does not, however, restrict what commands that this HMI computer is able to send to this protected PLC. That's the job of the Modbus Enforcer module. Let's go add that module to our Tofino configuration. So to do that, we're going to look at the settings for the Tofino security appliance. I double-clicked on this Tofino icon, and on that Tofino, we're going to switch to the Modules tab, and we're going to add the Modbus TCP Enforcer module to the configuration of this Tofino appliance. Let's go ahead and select the Modbus Enforcer LSM and click the Activate Module button. That will instruct the CMP software to download and activate the Enforcer module into the Tofino security appliance. And after a few seconds, that module is installed and activated. Now let's go back to our PLC and have a look at what we can do to configure this device. When I open up the settings for the PLC, we now see that we have three tabs for the PLC. We have the original General Settings tab, which is where we can configure the name and IP address of the device. We still have our Firewall tab, which was there before. Now we have a third tab labeled Modbus TCP Enforcer, and at the moment that tab is empty. So how do we actually engage the Modbus Enforcer on this connection between the HMI and the PLC? Well, that's done first of all by making a minor change to the firewall rule that is allowing Modbus communications between the HMI and the PLC. If you look at this rule right now, let's double click on it. You can see that it currently has a permission setting which is set to allow. This is a blanket allow, meaning all packets between the HMI and the protected PLC are allowed to pass through the Tofino, regardless of their content. What we want to do to bring the Modbus enforcer into the picture is to change that permission from a blanket allow to this option at the bottom of the list, which is enforcer. And what that tells Tofino is no longer are we just going to ignore the content of that traffic and allow every packet through. We're now going to ask the Tofino Modbus enforcer module to look at each packet and make sure that it's matching the rules that our engineer has set out for us to decide whether or not the traffic is allowed through. After we make that change, we can now go back to our Modbus TCP Enforcer tab, and we now see that the HMI computer is now listed on this tab as a talker that is going to have its traffic inspected by the Modbus Enforcer. On this tab, this is where we can build a list of which function codes we're going to permit to pass through the connection. Now, in the interest of time, I'm going to go ahead and I'm going to set up one of the function codes here. I already know which function code it is. It turns out that this HMI uses function code number 3, which is a read holding register function code. And it reads a block of 100 registers starting at address 12288 and extending all the way through to 12387. So I'm going to go ahead and add that rule to permit that function code to pass through the Tofino. So, just to review, we have changed our firewall rule permission to enforcer rather than a blanket allow, and we've added a single function code to the list of permitted function codes that can pass through this connection. If we had other talker devices that were also communicating with this PLC using Modbus, we could have another list on this same tab for those other talkers as well. But for now, we're just dealing with one. Let's go ahead and save those changes. Now, our Tofino is already in test mode, so we're not going to make any change to the actual traffic. We're just going to see how the system responds with those rules in place. So that new enforcer configuration has now been saved to the Tofino appliance, and so far so good. It looks like our system is performing as expected. The HMI software is continuously polling process variables from our simulated chemical plant, and it looks like they're getting through that in the Modbus connection just fine. So let's see what happens if the HMI tries to send, oops, just ignore that man behind the mask. Let's look at what would happen if the HMI tries to send a Modbus command that is not on our list of permitted commands. I'm going to do that by clicking on this button, which is a button in the HMI that allows us to change the set point on the plant. So let's make a change of the set point from 600 liters to 555 liters. When I hit OK, well, that would require a write command to be sent from the HMI to the PLC. And sure enough, we can see on the HMI the set point did change. It's now 555, just as we asked. But we also see an alarm message that was generated by the Tofino. What is it telling us? It says, this function code number 16 is not a permitted function code. And it also tells us where that command came from and where it was going, just like we've seen in earlier examples. So clearly we need to, if we want to permit that traffic to pass through, we need to add another function code to our list. And the code we need is function code 16. So let's go through the process of adding that. I'm going to go back to my Modbus Enforcer configuration, and I'm going to add a new function code there, function code 16. Let's find it on the list. There it is, write multiple registers. So now we have the function code, but we don't know which actual register our HMI is writing. So I'm going to set a a function code with a dummy range of just one register here, and we'll see what happens when we try that again in test mode. So I've just saved those changes to the Tofino security appliance. Let's go and acknowledge those alarm messages, and let's once again try that set point change. Change it. Let's change it back to 600. Now we get a new alarm message. The change did take effect, and that's because we are in test mode, but we did get another alarm message. And now we know that not only are we sending a function code 16 from the HMI, the register it's actually writing is this register value right here, 12294. So that's the register we want to allow. Remember, we want to try and keep the rules here for both the firewall and the Modbus enforcer to the minimum set of rules that are required for correct planned operation. We don't really want to allow this HMI to write any more registers than it really needs. So let's just allow it to write that one register that we know it has to write. So I made that change in the Modbus enforcer configuration. Let's save that change. And let's perform one more test to see if that does the trick for us. I'm doing all this work, by the way, with the Tofino in test mode, because this way it's not changing any of the traffic passing through the system. It's just telling me what would have been blocked if the device was operational. One more test here, another set point change, and this time, okay, this is not an alarm message from the Modbus enforcer. This is an alarm message that is from other traffic that's not related to the Modbus testing we're doing right now. So we know now that we have successfully added the correct function code, and we've successfully added the right register address that this set point change needs in order to do its job. So let's go back and quickly review that. So on our firewall, we've modified the rule permission so that the enforcer is now checking the traffic going to and from the Modbus controller. And on the Modbus enforcer tab, we now have some rules that allow the minimum required Modbus commands and register accesses in order to let this HMI do its job without unnecessarily opening up any other Modbus commands that might potentially cause problems for us. So that's a very quick example of how to configure and test rules for the Tofino Modbus TCP enforcer module. Future videos will also cover some of the other enforcer modules that are available for Tofino. Thanks for your time today. I hope that you found this useful. If you have questions about the Tofino Modbus enforcer or anything about Tofino in general, please feel free to contact your local Hirschman Belden representative.